Hello student. So already we discussed the periodic classifications. Now I am going to discuss the different properties, how it will be vary along a period and along a group. So let us focus first size of atom. Size we need to know. Then size, if you understand how you will discuss the size, first you need to know along a group what will happen, or it is called as a top to bottom what will happen for the size. And the size of atom, it can be different name is there, covalent radii, ionic radii, metallic radii and van der Waals radii. I will come that one. Before that you need to know what is the general trend of the size along a group. So if you look at, there is an atom is there, the nucleus is there, around the nucleus the number of cell is there, and where the electron used to come over here. And the down the group what is happening, when you are going top to bottom, then n value, principal quantum number will increase, because the general valence electron, if you look at the sodium is 3s1, then potassium will be 4s1, then rubidium will be 5s1, like that it will be proceed on. So that means when n value will increase, the number of cell around the nucleus will increase, and the distance from the nucleus to the outermost layer of the electron is called as a size of the atom. So that is why as the n value, principal quantum number is increasing, then the number of cell will increase. As the number of cell will increase, the size will increase, because the distance from the nucleus to the outermost layer is nothing but the size, or outermost electron layer is nothing but a size of the atom. So that is why as the when you are going the down, the number of cell is increasing. You look at number of cell is increasing. So that is why the distance from the nucleus to the outer layer of electron is nothing but a size. So that is why as the number of cell is increasing, the size will increase along a group or top to bottom. Then along a period what will happen? Along a period what logic you have to understand? Along a period what is happening, when we are going, or it is called as a left to right in a periodic table. Left to right in a periodic table. What will happen? In left to right in a periodic table, effective nuclear charge, J star effective nuclear charge will increase. That means effective nuclear charge will be calculated by this way, J star effective will be equals to J atomic number Z minus S. S is a screening constant. S is a screening constant. And this screening constant can be calculated different by Slater's rule. That rule is there for the same level of n value, other electron will be contributed by 0.35 unit. N minus 1 level electron will contribute at 0.8. N minus 2 is contributed by 1. Like that you have to calculate the total S value, and then Z minus S is nothing but a Z star effective calculations will be there. And if Z star is nothing but a effective nuclear charge. Effective nuclear charge will increase means nucleus will be more powerful. Nucleus will be powerful. Nucleus will be what? Powerful. The nucleus will be powerful means force of attractions will be more. Force of attractions will be high. Force of attractions towards outer layer electron. Towards outer electron will be high. Will be high. So that is why when the force of attractions of outer layer electron will be high, then there will be a contraction of size. So that is why what will happen? The size will decrease. When you are going left to right, the size will decrease. The reason is effective nuclear charge will be more. As the effective nuclear charge will be more, nucleus will be powerful. Nucleus powerful means force of attractions will be more. Force of attractions of the outer layer of electron more means what? Then there will be a contraction of size, then the size will decrease. This is the basic trend of the size you have to understand. Once you understand this basic trend of the size, then you look at what we have to do for the covalent radius, ionic radius, and this size for the atom. There are few categories there. What is that? That is nothing but the covalent radius, ionic radius, metallic radius, all those things will be there. Covalent radii. What is covalent radii? The covalent radii will be nothing but whenever two atoms is forming the covalent bond. This is the scenario of a covalent bond. This is atom 1 and this is atom 2. in between distance I am taking you nothing but a AB, and this half of the distance is called as a covalent radius. So that means AB distance is nothing but a x, and then covalent radii will be equals to x by 2. Half of the distance between two covalently bonded atoms is called as a covalent radii. So that means we are considering the two atoms which is forming the covalent bond, and in between the distance this there is nothing but x. So in between the two nuclei distance will be nothing but x. Half of the distance will be nothing but x by 2 is called as a covalent radii. Now you understand what is the covalent radii. Then ionic radii. What is ionic radii? Ionic radii will be nothing but the two ion, cation and anion. Generally cation will be smaller size, and then anion will be, this is a cation and one will be nothing but anion. They will just touch by each other. This is a cation and this is a anion. And now this is a nucleus of cation, this is a nucleus of anion. Half of the distance, suppose I am telling this distance is Mn. Mn is nothing but I am telling y. So then the ionic radii will be equals to nothing but what? Y by 2. Half of the distance between the two cation and anion, so which is forming the bond in between the cation and anion, that is called as a ionic radii. That means two ion means that they are touching to each other. They are not overlapping. In covalent bond, sharing of electron, and ionic, what is? Complete transfer of electron. That is why in that case they will touch, cation and anion just touch to each other. Then the half of the internuclear distance of the cation and anion is nothing but a ionic radius. And then metallic radius picture will be same. Ionic and metallic will be same. Only in metallic means what? Electrostatic force of attraction between the cation and electron, but here cation and anion. That is why the two metal ion just will be touched by each other. This is a two metal atom. This is a metal atom and this is another metal atom. Both are just touched by each one. And then half of the distance of these two nuclei. Suppose I am telling this is Lk. So and then Lk will be equals to, I am telling, is nothing but A. So then the metallic radii will be nothing but what? A by 2. Half of the distance between the two metallic bonded atom is there, that is nothing but a metallic radii. And then van der Waals radii. What is van der Waals radii? Here itself I am doing van der Waals radii. Van der Waals radii, what will be there? Two covalently bonded atom is there. Here one covalently bonded atom and here another one covalently bonded molecule will be there. And then if I take the distance between the two atoms which is separately bonded in a covalent bond, this half of the distance, suppose I am telling this is nothing but the Z and Q, and this distance I am telling is nothing but a B. So then the van der Waals radii will be equals to what? Van der Waals radii will be equals to B by 2. Half of the distance between the two atoms which is separately in a different covalent bond, that is nothing but a van der Waals radii. Also from this picture, if you remember the picture, you can easily understand this concept. This is a covalent bond, means sharing overlap completely. Metallic ionic means just touching, and then van der Waals means two different covalent molecules we have to consider. In between the two atoms, half of the distance is a van der Waals radii. Then you understand, then we can say generalizations. Van der Waals radii will be greater than what? Will be greater than metallic or ionic radii. Metallic or ionic radii. And then metallic or ionic radii will be greater than covalent radii. This is the concept you have to understand regarding the size. That means maximum radii will be there for what? Van der Waals radii, because two different covalently bonded molecule we are considering, and from one atom for this molecule, another atom for this molecule, and half of the distance. That is a van der Waals radii. That is why van der Waals radii will be greater than the metallic radii. Metallic radii means what? Or ionic radii, two atoms just touching to each other. That is why this distance will be more, and half of the distance also will be more, and all cases half of the distance. And here two are encroaching to each other, two are overlapping to each other. That is, this distance will be less. So that is why in this case we can say van der Waals radii is greater than metallic radii is greater than covalent radii. Got the point? This is the concept you have to understand. After knowing these things, few things I want to discuss regarding the size, you have to understand clearly. What is that? Suppose if you look at that, I am telling sodium cation and I am telling sodium. So, which one is a bigger size, which one is a smaller size? This type of things how you will analyze. Here sodium plus means there is a how many electron? 10 electron will be there, because generally in neutral sodium there is a atomic number 11, 11 electron and 11 proton. 1 unit positive charge extra means the one less amount of electron will be there. 10 electron is there and then 11 proton will be there. Proton will attract the electron. But here 11 electron and 11 proton. You know 10 electron is attracted by 11 proton. Here 11 electron is attracted by 11 proton. Here the power of the proton will be more, because only it is attracted the 10 electron. Then the force of attractions will be more. Contraction of size will be there. Then the neutral sodium size will be greater than the cationic. These things you have to understand. Size of neutral sodium is greater than the cationic sodium. Suppose here itself I am writing chlorine and here itself I am writing Cl minus. Then here how many electron? There will be 18 electron, because chlorine atomic number is 17. 1 minus means extra 1 electron is there, but the proton is same, 17 proton. Here 17 electron and 17 proton, neutral chlorine atom. Because now you look at 17 electron is attracted by 17 proton, whereas 18 electron is attracted by 17 proton. Here the force of attraction will be maximum. So that is why Cl minus will be greater size than the neutral Cl. So that is what you have to understand. Cation has always smaller size than the neutral atom, and the anion has a bigger size compared to neutral atom. This is the basic idea. First you understand this way, and after understanding these things, they will give you the questions. Write down the size order. What will be the size order? What will be size order? What will be radii order, or what will be size order? They will give you like this, and then they will give you F minus, and then they will give you Na plus, then they will give you aluminum plus 3, and then they will give you Mg plus 2. What will be the size order? This type of questions they will ask over here. When you will address this type of questions, how you will do? Here you write down fluorine atomic number is nothing but a what? The 9. So then minus means extra 1 electron is there. 10 electron which will be attracted by 9 proton. Atomic number means that is signify that many number of electron and that many number of proton, and minus charge means 1 extra electron is there. So now Na plus means extra less amount 1 electron will be there. 10 electron which is attracted by 11 proton. Here aluminum atomic number 13 plus 3 means 3 unit electron is less. So that is why 10 electron which will be attracted by 13 proton. Here the magnesium is atomic number is 12. So that is why 2 unit less electron is there, 10 electron which will be attracted by 12 proton. First you will write down the how many electron is there, how many proton is there in that species. Then in front of your eyes everything will be clear. Here 10 in all cases 10 electron. That means all species is nothing but what? Isoelectronic species. Already in the atomic structure we discussed these things. The same number of electron is called as a isoelectronic species. So that is why here 10 electron is attracted by 9 proton, whereas here 10 electron is attracted by 12 proton, 10 electron attracted by 13 proton. Where the 10 electron is attracted by 13 proton, the force of attraction will be maximum, then there will be contraction of size, that means the size will be minimum. So that is why the size order will be what, my dear? Size order, aluminum plus 3 will be the least size. Before that there will be the magnesium plus 2, and magnesium plus 2 will be the least size compared to Na plus. Na plus will be least size compared to F minus. That is why F minus will be the biggest size and aluminum plus 3 will be the least size, because F minus 10 electron attracted by only 9 proton. Force of attraction will be less, size will be more. When the force of attractions will be more, then there will be contraction of size. So that is why aluminum 3 is the least size, F minus will be the biggest size. I hope you understand, my dear student. Anybody has any doubt? Okay. So then come for the next things, the ionization energy or ionization potential, or they can say ionization enthalpy, same thing, ionization energy or ionization potential or ionization enthalpy, the same thing. So then you have to look for ionization energies, or ionizations enthalpies, or ionizations potential or ionization potential, same thing, name is different, ionization potential, same thing, the name will be different, ionization energy or ionization enthalpy or ionization potential. In short, they will can say IE or ionization enthalpy or ionization energy or IP ionization potential. They will say like this way. So now, the first of all, along a group or top to bottom, along a group what will happen? General trend, along a group what will happen, my dear? Along a group, if you look at the ionization energy order, if you look at along a group what is happening? The number of N value will increase, number of cell will increase, just now we discussed, the size will increase. As the size will increase, the attraction of a nucleus to the valence electron will be very less. So that is why, what is ionization energy? Ionization energy is nothing but the amount of energy required to knock out one electron from the valence shell which is loosely bound in its gaseous conditions. That is nothing but ionization energy. So that means when the size will be big, the force of attraction to the nucleus to the valence shell will be less. So that by giving less amount of energy, you can knock out the electron. That means ionization energy will what? Decrease, because the force of attraction is less. You can easily knock out the electron by applying less amount of energy. Ionization energy will what? Will decrease along a group. So that is what, if I take any element, suppose I am taking the first group, then I can say ionization energy order, lithium is greater than the sodium is greater than potassium is greater than rubidium is greater than cesium. We can write down like this, because down the group number of cell will increase, size will increase, ionization energy will decrease. Whereas along a period what will happen? Along a period or left to right, whatever you call it, what will happen? Along a period is nothing but a Z star effective will increase. Z star effective increase means the nucleus will be more powerful. Nucleus will be more powerful means force of attraction will be more. Force of attraction more means contraction of size is there. To knock out the electron, what do you have to do? You have to apply more amount of energy to knock out the electron. Ionization energy will increase. Ionization energy will increase. That is what, if you have carbon, nitrogen, oxygen, and suppose has, or you have a like this boron, carbon and nitrogen. So then this nitrogen will be greater than carbon will be greater than the boron. This is the general rule. But there are certain exceptional cases will be there, we will discuss regarding the ionization energy. Suppose there is a one metal is there, M is a metal. So then when you are supplying the ionization energy to knock out the first valence electron to convert to M plus 1, this is called as a first ionization energy. To want to remove the second electron from the valence shell is called as ionization energy 2. Then immediately it will be converted to M plus 2. To remove the third electron from the valence shell, it is called as a third ionization energy, and to convert from M plus 3. So then M to M plus 1 ionization energy 1, M plus 2 M plus 1 to M plus 2 ionization energy 2. So that means to remove the second electron ionization energy 2, to remove the third electron ionization energy 3, to convert M plus 3. Always ionization energy 3 will be greater than ionization energy 2 will be greater than ionization energy 1 for the same element of atom. Why? Because when you are removing one electron, effective nuclear charge is increasing, because 1 unit of protonic charge will be higher. So that is why force of attractions will be higher. When the force of attraction is higher, the knockouting the electron, you need more amount of energy. That is why always ionization energy 3 will be greater than, ionization energy 2 will be greater than ionization energy 3. And they will put a questions like this. There are 3 electron removal is there from the particular metal. And for first electron removal, they are telling energy required 4 kilojoule, and the second electron removal, their energy required is nothing but a 10 kilojoule, and then third electron removal, the energy requirement will be there 100 kilojoule. This metal, if it is from the chloride, what will be the formula of the chloride? Like that question they will give. Then from there, what you have to understand? So that means first electron removal means ionization energy 4, second electron means 2. How many times? 2.5 times. Now 4 into 2.5 is nothing but how much? 10. And then from 10 to 100, how many times? 10 times. That means if you look at that any metal like beryllium electronic configuration is 1s2, 2s2. So now if I remove one electron, then beryllium 1 will be nothing but a 1s2, 2s1. If I remove further electron, beryllium plus 2 is 1s2, 2s0. And then beryllium plus 3 means 1s1. So now if you look at this idea, removing the 2 electron is nothing but a valence electron. To remove all the valence electron, less amount, comparatively less amount of energy required. When we are coming to 1s, to remove the 1s electron, it is a core electron. To remove the core electron, you need huge amount of energy. That is why where the energy difference will be very high, that means you have to understand there will be 2 valence electron is there, and this amount is removing third electron, means we are try to remove the core electron. By the data itself, you have to understand there are 2 valence electron will be there, because in removal of third electron, you need huge amount of jump of energy is there. So that from there you have to understand there are 2 valence electron is there into that metal. So that means the valency of the metal automatically will be there M plus 2. If it is from the chloride, formula will be what? MCl2. That is what you have to understand this type of questions. You got the point, my dear student. So now another things I want to discuss over here. Another things I want to discuss over here regarding the some exceptional ionization energy. Like the first ionization energy I am going to discuss for, they are giving beryllium, boron, carbon, nitrogen, oxygen and fluorine. They are telling what will be the trend of first ionization energy. According to our logic, left to right if I go, then effective nuclear charge will be increased. Effective nuclear charge increase means what? Force of attractions will be very high. Force of attractions will be very high means what? Force of attractions is very, very high, means to knock out the electron, you need more amount of energy. So that is why ionization energy will increase from left to right. So according to that logic, ionization energy order will be beryllium, boron, carbon, nitrogen, oxygen and fluorine. But actually this is not the order for first ionization energy. What order actually will be there? Beryllium is greater than boron, boron is less than carbon, carbon will be less than nitrogen, nitrogen again will be greater than oxygen, oxygen will be less than fluorine. This order will be followed. This is the order will be followed. Actual order should be like this according to our concept, but experimentally these things is observed. Why? In case of a first ionization energy. The reason is you have to understand over here itself. If you look at the electronic structure, so then beryllium electronic structure is 1s2, 2s2, whereas boron 1s2, 2s2, 2p1, whereas nitrogen electronic structure 1s2, 2s2, 2p3. 2p3 is a half-filled configuration, and oxygen 1s2, 2s2, 2p4. Now you look at whenever this you want to remove the one electron from the 2p, and whereas here you want to remove from the 2s, 2s is a full-filled configuration, and compared to 2p, 2s will be more close to nucleus. That is why the force of attractions over the 2s is very high, and as because of its fulfilled, the ionization energy, first ionization energy from the beryllium will be higher than the boron. This is the exception you have to remember. And then second, the nitrogen is greater than the oxygen. Why? The reason is to remove the electron, this half-filled configuration means I told you is a very extra stability because of the more exchange energy. So that is why to remove the one electron from the 2p3, it need more amount of energy, whereas to remove from the 2p4. That is what you have to understand. Now you look at these things. Regarding the first ionization energy, we got this order. For the second ionization energy, if I consider, second ionization energy in between nitrogen and oxygen, if I consider. So, after removing the first ionization energy, nitrogen electronic configuration 1s2, 2s2, 2p2, whereas oxygen will be what after removing one electron? 1s2, 2s2, 2p3. Now, the oxygen is a half-filled configuration after removing the first electron. That is why, as far as second ionization energy will be concerned, oxygen will be greater than the nitrogen, whereas first ionization energy is concerned, nitrogen is greater than the oxygen, as because of half-filled configuration. Half-filled configuration means the p orbital capacity of electron is 6, but here is there 3. That means half-filled is there. Half-filled means exchange energy will be more. With same parallel spin electron can exchange their position. That is phenomena is nothing but like a resonance. Because of exchange, the stability will increase. That is why half-filled configuration will get the extra stability. That is why in case of a first ionization energy, nitrogen is greater than the oxygen. As far as second ionization energy is concerned, the nitrogen will be lesser than the oxygen, because when you want to remove the second electron, after removing the first electron, nitrogen electronic configuration will be 1s2, 2s2, 2p2, whereas after removing the first electron, oxygen electronic configuration will be 1s2, 2s2, 2p3. So, that is why that time oxygen will be half-filled configuration. That is why to remove the second electron from the oxygen, you need more amount of energy. That is why second ionization energy of oxygen is greater than the second ionization energy of nitrogen. I hope you understand, my dear student. The next class I am going to discuss the all other properties like electronegativity, electron affinity, all those properties I am going to discuss. I hope you understand, my dear student. Thank you very much. Thank you all.